So list accessing problem. Cost at time t is the location of the requested file from the left in the stack of size. There are free exchanges and paid exchanges. So last time we saw that a lower bound which said that no randomized algorithm can have a competitive ratio less than 1.5. It was slightly more than this, but for large enough L, this is what it looks like. So now we want to come close to 1.5. Remember, move to front was a deterministic algorithm whose competitive ratio was close to 2. So we want to essentially move from 2 towards 1.5. So let's start thinking about what a randomized algorithm should do. So any idea, any candidate algorithms come to mind? Anything slightly non-trivial or even most natural randomized algorithm? Anyone?
So compute the place through, so the move algorithm that we used. So now there will be a probability distribution over the places where it can move.
Okay, so take move J algorithm for different values of J and randomize over them. Is that what you want to do?
Yes, yes, yes.
Okay, but we last time tried to argue that move J is strictly worse than move 1 for J greater than 1. We did, right? Do people remember this fact? We argued it 2 classes before. Because now the adversary's job is easier if you were to go from move 1 to move J. So do you still want to randomize over all of them?
We need to add some randomization also on paid exchanges because that's
Sorry?
paid
exchanges.
Yeah.
That's more complicated because you don't know anything about the future, right? So any algorithm which is doing paid exchange is going to be in trouble. Because if you do paid exchange and that file is never requested, you're unnecessarily paying for it.
That's also true.
Paid exchange for an online algorithm is a very difficult proposition. But you could simply think of move 1 itself, right? So move 1 is a reasonable candidate. Now you could possibly try to randomize this. How would you do it?
Fix some probability P of moving to 1 and 1 minus P of keeping it at the same position.
Very good. So algorithm with probability P, use move 1, probability 1 minus P, do nothing. Right? Now what do you think is going to happen? Do you expect this to perform better than move 1 itself?
I think it will do better because to full move on, we took some examples, right? DD. So we appeared the input twice. So I think in that cases, this will be immune. This algorithm randomized.
No, think about, let's take an example here. So suppose my input is of the kind, let's say input of size list of size 2 and L equal to 2. So files are only X and Y. Now let's say the input is lots of X's followed by lots of Y's, followed by lots of X's and lots of Y's. What do you think is performance of OPT? So what is the cost of OPT? And let's say beginning L0 is just Yx. So what will be the cost of OPT? It will be 2 plus lots of these one. Let's say that there are n k minus 1 of these. Then again 2 plus k minus 1. Then again 2 plus k minus 1 and 2 plus k minus 1. Right? People agree? Is this clear, right? That why the cost of OPT is this? Not clear?
Yeah, it is clear.
Okay. Now what is the cost of your algorithm? It's an expected cost because it's a randomized algorithm. So until the time it moves X to the front, it will pay 2. So 2 times, let's say time t, and plus k minus t minus 1 or k minus t itself. K minus t itself. Capital T is clear, right? T is the time at which your algorithm moves the file X to the front. And how long? So this is the same essentially everywhere. So it will be 2t plus k minus t and blah blah blah. So what is t for your algorithm?
About 1 over p.
Over p. So now what do you think? What value of p should I pick first of all? It's clear that
Yeah, it should be 1.
p should be 1. But then I have no randomization left, right? So I am back to move one algorithm. So when does do nothing is a good option?
When the file is only asked for once. Some file is asked for once, and then we ask adversary asked for different files. In which case, moving to front is unnecessary, I guess.
Yeah, so then you have to change your input in some sense. So you could potentially just replace this by single y, this y. So now, depending on t equal to 1 by p, your cost will depend on something like 2 times p over k minus 1 by p. So many times, that's a number of blocks. So here clearly p should better be 1. There is no other choice. But then if you change your input, so this randomization is turning out to be weird, right? So look at this. P and 1 minus p is turning out for the input, which is rather a reasonable input. The p equal to 1 makes more sense than p equal to anything below 1. So randomization, or rather what you say, may turn out to be trivial, or algorithm becomes deterministic. So for a particular choice, you'll do something in your homework. So for p equal to 1/2, you will try to show, or rather p uniformly random between L files. So p equal to 1 by 2 is fine. Try to show in homework that competitive ratio is actually close to 2. So you can't improve by just doing this randomization. Let's say it's close to 2. So the next one, so there's another way of permuting or randomizing our move one algorithm, which is called as what is known as the bit algorithm. So what it does is the following. So suppose this is your stack to begin with. So F1, F2, F3. Without loss, I'm just writing them in sequence. Assign a random bit to each file. So to begin with, this might look like this. So that's your starting bit index. Now on a new arrival, on a file request rather, flip its bit. If it's 0, make it 1. If it's 1, make it 0. And if after flipping it is 1, then move the requested file to the front. Is the algorithm clear? So I'm starting with some random bit sequence associated with each file. I'm only going to touch the bit index of the file requested. All right. So I'm always going to flip its bit index. So if it was 0, I make it 1, and in which case I also move the file to the front. If it is 1, I just make it 0 and do nothing. I leave it in its place. All right. So let's take an example just to make sure that we understand. So let's say F3, F1, F5, F2, F6, and F4. And at this point of time, 0, 1, 1, 0, 0, 0 is the bit index. And we'll take two examples. Let's say F5 is requested. Or F2 is requested. So when F5 is requested, all the other bits, all the F1, F5, I don't touch any others. So all these guys are 0, 0, 0. This is 1, 0. And because this was a 1, it is made 0. And because after flipping it is 0, we do nothing about file F5. While in the other case, when F2 is requested and its bit being 0, so now the new thing will be F3, F1, F5, sorry, F5, F6, F4, and now F2 will go to the front. Its bit index is 0, 0, 1, 0, 0. Oh, hopefully the algorithm is now clear. So it's very similar to what we were doing before.
Yes.
Yep. It's just keeping track of some bit sequence. So any property which comes to mind directly of this algorithm?
A file may take at most 2 power L minus 1.
Something much simpler. It has no dependence on L. See, each bit is acting independently. The bit sequence is changing for any file only on its own request. So the example I took was either F5 is requested or F2 is requested. They're not simultaneously getting requested. So for a file to move to front, how many requests have to be made? Guys, is the algorithm clear? This is a trivial fact.
Yes.
So given that algorithm is clear, how long does it take or how many requests do I need to make for a particular file before it moves to the front?
At most 2, right?
1 or 2.
Sorry?
At most 2, right?
Why at most?
Because if it is 1, then in the next step we'll make it 0. And then again, when we give a request, then it becomes 1 and we can move it to the front.
Yeah, so why at most? Why not exactly 2?
It starts out with 0, then you shift to 1 and move it at the first request.
Yes, yes.
Okay. Okay. Does everybody follow this? Property number 1. The way I want to write is that among the two consecutive requests to a file, the file moves to the front exactly once. Another property, what happens to the bit status? So bit status to begin with is uniformly random. Does it remain uniformly random throughout?
It actually depends on the input, right?
Well, that's the whole point. At any point of time, is it uniformly random or not? So what is the bit status at time t? That's the easiest way to think about it. Uniformly.
Yes.
Sorry. So bit status.
Unless the adversary systematically asks for all the zeros or all the ones, then it won't.
What do you mean zeros and ones?
I mean, for each file, it's either 0 or 1. Every time it's requested,
It doesn't see. That's the whole point. That randomness is hidden from it. To begin with, it doesn't know what is the status, right?
Actually, the adversary doesn't know about this bit sequence, right?
The original one, because that's all there is randomness in the algorithm.
So I think it will be uniform because the adversary doesn't know our bit sequence, so it can't fool our bit sequence in that way.
No, so just tell me what is the bit status of file f at time t, given what it was initial status was. You can write it down.
It's the same as the initial status if it was requested in even number of times, and opposite if it was requested odd.
Right. So in terms of number of requests and its initial status, can you write down a simple formula? So something like in terms of mod here, a plus here, and another mod here. Is that correct?
Yeah.
So this takes care of the fact that it's the number of requests is or odd or even. This takes care of that I'm adding it to the initial status, and just to make because it keeps toggling, it's another mod 2 out from the outside. Now is it obvious that this is uniformly random? If you're not convinced, just do like entropy, right? Just try to see the entropy of this bit status. See, all the information you have is the number of requests at particular time, right? So without knowing the initial status, which was uniformly random, what can you tell me about the bit status of file f at time t? That's the easiest way to think about it. Initial status was 0 and 1 with equal probability. At time t, I tell you how many requests I have
0
made.
and 1 with equal probability.
Right. So the information I'm giving you is how many requests I have made until time t. Should have added that. till time t. Now you did not know what the initial status was. Your information was either it was 0 with probability half and 1 with probability half. So then using this extra information about the number of requests until time t, what can you tell me about the bit status of file f at time t? What is the distribution of bit status of file f at time t? Think about that. Agnev, is this clear? Ashutosh, what is the distribution
It's 50-50, 0 or 1.
of bit status f at time t? See, clearly it is 0 or 1 because I have taken a mod 2. What is the probability of this being 0? Ashutosh, do you want to say? I just want to make sure that everybody is clear. This is an important property of the algorithm.
Yeah, half.
No, I'm waiting for other people just to make sure that they're convinced. Agnew, Yashwant, Ashutosh,
Can you say this once more?
Yeah.
what should I say?
Why this? How we are getting these probabilities?
How is this formula okay to you? First of all, tell me that. Then we can proceed towards looking at the distribution. Is this clear or not clear? If it's not, say no, and we move on. Don't hesitate.
No, sir.
Okay. Is the algorithm clear? Let's backtrack. Again, say yes or no.
Yes.
Algorithm is fine.
Our algorithm is clear. We wrote the first property that among the two consecutive requests for a file, the file moves to the front exactly once. So it's not this once. Is this property clear?
Yes.
Okay. So in two consecutive, so suppose the bit sequence was 0 to begin with for a file. After two requests, what will it be?
It will be 0.
So file, let's say file 0, file f had the initial bit sequence 0. I ask for f, it becomes 1. I ask for another f, it becomes 0. I ask for another f, it becomes 1. And I keep doing this, right? There could be a lot of gap here. I don't care. Nothing else happens because on request to any other file, the status of f doesn't change. This keeps toggling. Okay, so if this was 0 to begin with, and if I tell you that I have made 10 requests to f, what can you tell me about the bit sequence, bit index of f? Guys, is the question clear?
0.
Okay. What about 11?
Again 1.
What about 12?
0.
I know I'm belaboring the point because I was unable to understand why this is not clear. So what is this? Modulo number of requests till time, comma 2. What does it count? The number of requests are odd or even. Correct?
Yeah.
Okay. So if the number of requests are even, what do you do? If the bit status was 0,
Yeah.
and if the bit status was 0, if the number of requests was even, odd,
It would be 1.
so that's all. So
Yeah.
this part is clear.
Okay.
And plus the initial status of the file f, because that's where it matters, if it is 0 or 1. And overall mod 2, because I bit status is between 0 and 1.
Okay.
So something is not clear, stop me right there. I don't want to go ahead if somebody gets it. Somebody gets it, that's okay. You should not feel shy that you didn't get it. So is now everybody clear about what is the bit status of file f at time t? If there is any hesitation, please ask. Okay. So if there is no hesitation, then are we in a place to compute this distribution? So what is the randomness involved in bit status of F? The number of requests is known to everybody. The whole world knows how many requests you have made until time t. So the only randomness in this is the initial status, and which is uniformly random. So it continues to remain uniformly random. Is that point okay?
Yes.
All right. So then we have tick mark this also, that yes, the bit status of each file is uniformly random at any time. This is important for analysis. That's why I'm belaboring this point. All right. Any other questions about algorithm before I proceed towards analysis? Ask as many questions as you can. Never feel shy about a question. Okay. So theorem we want to prove is that mu bit is at most 7/4. That's what we are trying to do. So we'll not get to 1.5. There are actually better algorithms than bit, which are better than, which have computative ratio better than 7/4, but still not close to 1.5. So that's the current state of art. So what we're going to do?
This uniformly randomness is coming because you're adding the initial status, right? Till that point,
Just look at what
this
is the randomness in this. Number of requests is not random. Right? Number of requests
right,
at a
right,
particular time t is completely given to you.
correct, correct,
That's a deterministic quantity.
right. So
So
randomness
you're
is
adding,
when
so you're adding a deterministic 0 or 1 to a random 0 or 1. Just
zero
think
or
about
one.
it.
Yeah,
You have a bit which is uniformly random. You're adding an arbitrary 0 or a 1 to it.
right,
It
correct.
remains
That
uniformly
makes,
random.
yeah, that makes the result uniformly random. Yeah.
That's all. Okay, so again another potential function. Hopefully you're not gone bored of this. This is like the bread and butter of online algorithms. So definition. So many times you've looked at not like pairs of files which are in one particular order. This time, pay attention to the ordered version of it. So an ordered version, an ordered inversion of a pair of file, or rather let's see. So y comma x, the order is important to be an ordered pair of files y. If y is less than x, that is y precedes x in bits list, and x less than y in UPT's list. So we're not counting both sides. I'm just counting for ordered ones. Y comma x. Y is less than y is ahead of x in bits list, while x is ahead of y in ops list. And on top, we're going to define an ordered inversion to be type 1. So OI, ordered inversion, is of type 1 if B of x is 0, and type 2 if B of x is 1, where B of x is nothing but is the bit index of file f, so not fx, at time. So we're defining at any particular time t an ordered inversion to be an ordered pair of files y comma x, where y is ahead of x in bits list, and x is ahead of y in ops list. In addition, if b of x happens to be 0, we call it type 1 inversion. Otherwise, we call it a type 2 inversion. Does two people get that y is called 1 and 2? So if b of x is 1, What is so special with respect to this algorithm? How long does it take for this file to go to the front?
2 steps.
That's why
Two
it's called type 2.
requests.
Yeah, that's why it's called type 2. That's the easy way to remember it. Because the 2 will show up. While b of x is 0, it will just go to the front in one step itself. So that's why you can think of it as step 1, step 2 rather than type 1, type 2. So the potential function phi of t is going to consist of two parts, phi 1t plus 2 times phi 2t, where phi 1t and phi 2t are the number of type 1 and type 2 ordered inversions at time t. Is the definition clear? So
Yes.
phi1 counts all the ordered inversions there are at time t of type 1 and phi2t similarly of type 2. And this 2 gets multiplied exactly because of the same reason, that it requires 2 steps for these guys to go to the front. So just tell me if this is okay. And phi of t is greater than equal to 0 for all t. Are these two facts true? This is true because we start with the same configuration, so there are no ordered inversions. And why is this true? Just by the definition. So what we are going to show is that the expected value of the cost of the bit algorithm at time t is a similar strategy to what we have done. Del phi t, where del phi t is nothing but difference between p is less than equal to 7 by 4 times c. That's what we'll try to show. All right. So mostly it's pictures. So consider the proof is actually pictures. Consider time t when file x is requested. Let I be the number of ordered inversions of the form y comma x just before the arrival of x. And on top, let x be in the kth location with the OPT. Can somebody tell me in terms of k and I, what is the cost of bit t? See, cost of the algorithm at time t is the location in which that particular file is. With the OPT, we have said it is at the kth location. So that's the cost of the OPT. Now I is defined to be the number of ordered inversions of the form which involves file x. So y comma x just before the arrival of x. So can you write this in terms of k and I? What is, let me just write if you want me to write, is the cardinality.
Plus I?
Sorry,
Is it k plus I?
that is correct. So y comma x such that y is less in bit X is less than Y in opt. Now can you tell me with an expanded form of I? Does everybody follow why it is k plus I? If not, ask me. So this is in fact k plus I. So why k? So this is OPT's list. So X is in the kth location. So that is clearly how far it is for OPT. Now with respect to, this is my bit. As a function of I and k, where can you tell me my file X is in bit? That's my cost of bit, right?
Yeah, so the inversions will also be before X, right?
Okay.
So they will be added. So there will be K plus I, right?
Can you say it in some other words? So I've already got until here, right? Now
So the inversions are the files that are in OPT actually in XY form, but in our algorithm, the bit algorithm, it's Y comma X form, right? So they are before. So in OPT they are after X, but in bit algorithm they are before X. So they will be counted, right?
I just wanted to say it more crisply. So what if X is here? Is it possible?
Like the rest of the files in the OPT, other than those I files, will have the same relative order. So the only difference between OPT and bit would be those I files, which will be after X in the bit.
Okay, so suppose X is here. Is it possible or not possible?
No, because before X there are K files. Otherwise, that K, like, it would be more than I, because like those K files before X, which were in OPT, must also stay before X in the bit.
Okay, so let's call them F1 through Fk minus 1. Okay. Now what do you want to say?
Like this F1 to Fk minus 1, these files will also stay before X in bit.
Why?
Actually, that's not necessary. Because
Yeah,
it's
yeah, that's
already
not
mentioned.
the
This is
I.
a upper bound, so at most k minus one of those files. Okay. And there will be I other files which are in front of X.
So what is the consensus? I'm hearing lots of different things.
So there are I files which are after X in OPT, but they are before X in bit.
Yes.
And out of F1 to Fk minus 1, at most k minus 1 of them can be before X. So the
Okay.
cost of retrieving X is at most k plus I.
Yeah.
So equality is not correct?
No, I don't think so.
Are people following any of this? Yashwant?
Yes.
Can you repeat once again? I'm getting confused now.
Okay, so what is K? K is the location of file X with the OPT. Right? That much is clear?
Yes.
Okay. Now in the bit, where can this file be? Either before X or after X? Oh, sorry, after kth location is here. So either before K or after K.
Right.
If it is before, then it is at most K. You know that, right?
Right.
Now if it is after, use the definition of I. How much after can it be? I is counting all pairs where Y is ahead of X in bit, but X is ahead of Y in OPT. So only those many places exist here, I minus ones. So suppose
Right.
X is here. How many places are possible using my definition of I? So all these files, these Y files are ahead of bit, but they have to be behind X. So they have to lie here, correct?
Right.
So Y is ahead of X in bit and X is ahead of Y in OPT. So at most I can travel from starting from the kth location to I minus one of them and plus one for this one. So overall, this is at most K plus I. Is everybody okay
Yeah.
with this? So this is the way to, and K being the cost of OPT, I can write it as COPT time T plus I. All right. So that takes care of what is the cost of C bit. Now I want to care about what is my del phi of T. So what makes this change? So this is, remember, is phi of T minus Pt minus 1. Why should it change in the first place? And what kind of changes give it the contribution to this? So there are three types. Can somebody point out what are the three types of things which will actually change phi or which contribute towards del phi?
So bit of X has changed.
No, that is true. But remember, phi t is nothing but the number of type 1 and type 2 ordered inversions. That's all.
Yeah, so X might move from type 1 to type 2 or type 2 to type 1.
Right. No, no. So just say in words what exactly is happening. That some removal of old inversions or removal of old ordered inversions, creation of new ordered inversions, and type change of ordered inversions. These are all possibilities. Right? If the bit changes, the type can change. If OPT does something, it might remove or create new ordered inversions. Or bit itself can create or remove new or remove some old inversions. Is that all there is to it? Agnev, is this okay? Or there's
Yeah.
something else which can happen? See, all I'm keeping track of is the number of ordered inversions. So either they can go up or they can go down. The third thing which is important here is that there is a type also which I have defined. So the type might change. It could go from 1 to 2 or 2 to 1. So I have to keep track of three things. So let's say creation, the number of new created ones, let be n, removal be r, and type change be t. Okay. So these are number of things happening. So R is the number of old inversions which are removed, N is the number of new inversions created, and T is the number of inversions changing type. All right. So now, can people find a connection between R, T, and I? I was as defined above. I is this. R is the change in phi because of some old inversions going away. N is the change in phi because of some new inversions coming in. I want you to think about connecting R, T, and I. First, guess it. What should this be? Is there any connection between R, N, and I? Leave the T for the moment. We're not going to worry about T for the moment. Is the question clear? What we are interested in? We're looking at a connection between R, N, and I. I is well defined, hopefully to everybody. R is the change in phi because of removal of old inversions. And N is change in phi because of creation of new ordered inversions.
So if X is moved to the front, then all of the I inversions will go away.
So do that, you can use this, right? So suppose b of x is 0. Then what is going to happen? Then b of x will actually, so x will move to front. So say whatever you want to say. So what will be destroyed? Something will be destroyed.
So all the
Shomajit, go on.
so all the inversion with respect to x will be destroyed.
Okay, so all I inversions are removed. Correct? What happens to n? Does anything get created?
No.
And what about t? So leave n out. Sorry, I don't want relation between rt and I. I want relationship between. I want something wrong. R, sorry, R, T, and I, not R, N, and I. So leave n out. So this is, does everybody follow this? That because x is moving to the front, the set of inversions involving x in the second coordinate, they all disappeared. Just to look at this set, y comma x have disappeared because there is no file y which is ahead of x in bit. Nishan, Agnew, everybody is following?
Yeah.
Okay, so all i's are gone. Now what else can happen? Can anything else happen? With x goes to the front. What happens to the type?
So exchanges from type 1 to type 2. But
Okay. So is there any
that
change to
doesn't
phi?
change. There's nothing because then, I mean, the number of inversions with the x on the right coordinate is 0 afterwards. So
So type 1 becomes type 2, but no change in phi. Now when b of x is 1, now what happens? X remains where it was. But type, so no change to the I, right? I remains I. But type 2 goes to type 1. So now what happens? What is the change in phi? So remember b of x is 1 just before x is arriving. So it was a type 2 inversion. But once I flip the bit, it becomes a type 1 inversion. The same number of inversions stay where they are. And my, just to
the
recall,
I inversions will become type 2 to type 1. So they will. So
this was
phi will
my
reduce
original
by-
thing. Now this guy is going down. Is that what is happening? So number of type 2 inversions are becoming type 1 inversions, right?
So minus I, right?
Right. So changes. Similarly, see here also it was I inversions removed, so it's actually decreasing. So that's also minus I. So this is also changes minus I. So overall, what you can say is that the expected value of R plus T is actually minus I. So let's call this. Is everybody comfortable with this? I'm happy to go back. If not, R is the change in phi because of removal of some inversions. T is the change in phi because of change of type of inversion. So R comes into picture when b of x is 0. And this comes into picture when b of x is equal to 1. See, if a file is not requested, nothing is changing here. So we are only worried about the file being requested being x. Now the algorithm bit either moves it to the front if its current bit index is 0 and it leaves it as where it was if the bit index was 1. But because we have defined this type 1, type 2 inversions, even when the bit index is 1 and the file does not move, the type of inversion keeps changing. So that is why this phi2 becomes phi1 for all the I inversions. So the change is minus I in both places. Are people okay? If not, right now is the time to ask. We are not going to come back to R plus T. We are only going to worry about the new ones. Create. So let's worry about expected value of n. The new ones create. Now we'll worry about OPT. And for that, picture is sufficient. So let's say, remember x was, we said it's in kth location. Assume that OPT moves x to the k prime location on request 2. And this is z k prime plus 1. K minus 1. z1, z2, dot 2, z k prime minus. Okay. And this is our somewhere. With the bit. All right. Okay, so if OPT moves x ahead, what can happen to phi? What can happen to the ordered inversions? Guys, say something. This is my eye.
Actually, can you repeat the question? I couldn't get it.
Question is, if OPT moves x ahead, see, until this point, we are not bothered about what OPT is doing. Only said, because of the algorithm, what change is going to be made to the potential function phi. But OPT also can act. Now OPT moves x ahead. What can happen to the ordered inversions?
They should remain same, right?
I.
Because
What is I? Remember, I is the cardinality of y comma x such that y is ahead in bit and x is ahead in y in OPT. Now tell me, why should it remain the same?
Because in OPT the y is after x, right? So if we move x forward in the forward position, so it will not increase the number of inversion or change it.
Think of ordered inversions of this type.
Yeah, x. So x will
Not y comma
come
x.
in
Think
front
of
of
x.
some files.
Yeah, think of x comma f, not y comma x. What can happen to these? See, these are also counted, right, in the ordered inversions. So this will be removed. This type of inversions will be removed. Then potentially remove OIs of the type x comma f. Do people agree? See, your argument was of the ordered pair y comma x, which will be correct. But what about x happens to be on the first coordinate? So what does this mean? That x is ahead of f in bit, but f is ahead of x in OPT. Now OPT is moving, so these guys can actually get destroyed. Is it okay?
Yes, yes.
So the contribution of OPT to phi of t towards r and t is actually negative. So we can safely is in terms of n, that's not true. So we'll worry about n. It's negative. So we just don't care about it. We just say this is okay even with counting the OPT. Okay. Now we'll worry about expected value of n, the new ordered inversions created. Are we okay? I'm worried right now. Are people following this or not? Agreed. You're not saying enough. Agnew,
Yes.
are you following everything?
Like
Answer is yes or no. And tell me which part you followed and which part was not clear.
like uh, like after that inequality, that is expectation of r plus t is less than equal to
Minus
minus
I.
I.
So this is only contribution from the bit, right? You also have to worry about what OPT is doing because that will also change the potential function.
Yeah.
So I'm just trying to argue that that change is only negative, so I don't have to worry about it.
Okay. Okay.
In terms of R and T, in terms of N, it will be positive, which I'll have to count. All right. So now worry about expected value of N. N is the contribution or change in PT because of new inversions created. So look at this picture. Can somebody tell me what is going to happen because OPT is moving X from location K to K prime? And think of the case when B of X is 0. Then we'll worry about B of X equal to 1. So when B of X is 0, algorithm also moves X to the front. Correct? See, OPT is moving X from location K to K prime, while algorithm will move it to the front location if B of X is 0. So how many new inversions can be created in this process? So think about X comma Zi, so I going from 1 to up to K prime minus 1. Is this an ordered inversion? So these files 1, 2, all the way to K prime minus 1.
If bit moves X all the way to the front, then yes.
Right, it is the B of X is in fact 0, right? So it is moving.
Yeah, so then it is an inversion.
So these are OIs newly created. Are people with me? See, X is now in the first coordinate. So X comma Zi pairs are the newly created ordered inversions when B of X was 0. And what type are these?
Yeah, these are newly created inversions.
No. The newly created ordered inversions true, but which are the type? What decides the type of the inversion? The bit of the second coordinate.
Type 2.
No. Bit of the second coordinate.
A bit
What
of the
was it?
second coordinate. So
Right? Remember, where is my definition? Yeah. So define an ordered inversion to be an ordered pair of files y comma x. If y is ahead of x in bit, x is ahead of y in opt, and it's of type 1 if the second coordinate x has b of x 0, and it's type 2 if it is b of x equal to 1. So what am I doing? By doing all this, I am creating these many new, sorry. So I am creating new OIs for files x comma zi with type 1 plus b of zi. So if b of zi was 0, it's type 1. If b of zi is 1, it's type 2. All right. Now let's look at when b of x is equal to 1. Now what happens? The file number, sorry, the algorithm doesn't move it anywhere. This guy is moving it here. So how many new ordered pairs are created now? So this file is remaining where it was. So only changes with respect to these guys. And how many of them are there? X, Z, J, J going from K prime to K minus 1. Guys, say something. I need some feedback. See, if b of x was 1, the algorithm bit did not change the location of x. But OPT is making the change. It's moving the file from the kth location to the k prime location. So for the in between files, zk prime plus 1 to zk minus 1, the inversions will be created. And how many of these are there? Exactly k prime to k minus 1 of these. And what is the type of these? Which type inversions am I creating?
I guess 50-50 because we don't know the type. Wait, is this?
Think about. We're creating new ordered inversions, right? What type are these?
These are type 0. Type
Why?
1.
Why?
Because x, the bit will be set to 0.
No, but remember, ordered inversion, the type comes from the second coordinate. We just, should I go back? So y comma x is an ordered inversion of type 1 if b of x is 0 and 2 if b of x is 1. Right?
Okay, so the type of x actually.
No, so if x comma zi is an ordered inversion, then type of that inversion is dictated by who?
Zi.
Yeah, so why is it type 1? What did it do for the first case? B of x was 0. We said the type of inversion created depends on the bit index of those files with the algorithm. Why are we not saying that here? We just said this, right? That new ordered inversions for files x comma zi are created with type 1 plus b of zi. Do people have an like people accepted this? I say something.
Yeah.
So now what should be the case now?
Same 1 plus b of z.
Sorry,
It should again be 1 plus b of zj.
but is this correct? Is this the new inversion created or is zj comma x? What is the ordered inversion?
It's
So x or rather let's say y comma x is an ordered y if y is ahead in bit and x is ahead in OPT.
It will be zj comma x.
I'm just making sure that people are alive. So what kind of inversion is this? Is this correct? Or I need to change something here? Vishwant, Agnew, speak something. I know things are not moving as smoothly as you would like. So talk to me. Is it clear what is going on?
It should be zj comma x.
Okay, let's vote and see if the majority wins. Now tell me if is it ZJ comma X type or X comma ZJ type. X is moving ahead, okay? It has gone to K prime. So ZJ is where with respect to bit?
So the explanation is that these files were not in I mean before the move, right? In the ordered inversions, these
Yeah.
files were before x, right? So it was not an ordered inversion, but when x moves
Because of the X movement, something is increasing. So we're only looking at how much increase can happen.
so these files are now in the inversion with x in bit algorithm, right? The new inversions.
Correct. So these files were also here because there was no inversion. Right?
Yes.
And now X is moving ahead. What can that result in?
Zj comma x.
So this is not correct. And that is why this is a type 1 inversion, because the inversion comes from the second coordinate where X has bit 0 after change. Correct? So number of them is Zj comma X for j going from K prime to K minus 1 of type 1. Guys, Agnew, Yashwant, please talk to me. If anything is not clear, please ask.
Yeah, sure.
Okay. So should I proceed?
Yeah.
Okay. So what have we done? We have said that the number of new inversions created because of the file moving because of OPT or the algorithm. In case when b of x was 0, in which case the algorithm also moved x to the front, is so much. And when b of x was 1, when the algorithm left the file where it was, is so many. So now I can compute expected value of n. And now this is where I will use the fact that b of x is 0 and 1 with equal probability at any point of time, which I belabored to begin with. Remember, the bit status of a file is uniformly random at all points of time. So that is why I can say expected value of I going from 1 through, okay, I should say 1 through k prime minus 1, k prime minus 1, 1 half 1 plus b of zi plus k prime I equal to k prime to k minus 1, another 1 half type. Is this inequality clear to everybody? This is the probability with which b of x is 0 and b of x is 1. If it is half, sorry, if it is 0, this is the increase in my potential function. And for how many files? K prime minus 1. For this is just I count 1 because everything is type 1. So I don't have to worry about this. And this can be written as, again, using the fact that expected value of b of zi is also uniformly random. I can just simply pull this out. 1 plus expected value of b of zi plus how much it is, k minus 1 minus k prime summation 1 through minus 1, which is equal to 3 by 4 k minus 1, which is 3 by 4 COPT. Why is that? Because by choice, K was the location in which X was with the OPTs list. Since X was in location K with the OPTs. Okay, so now we can simply, so what have we done? We initially did this. What did we say? This was K plus I. Then we said expected value of R plus T is at most minus I. And finally, we have said expected value of N is at most 3 by 4 COPT T. Therefore, C bit of T plus del phi T, which is nothing but these two components, that is most K plus I minus I plus 3 by 4 COPT T. And this is again another COPT. So COPT plus 3 by 4 COPT. This gives me 7 by 4 CO. Okay, so far nobody has objected that why have I not looked at OPT's ability to perform paid exchange. So should I care or should I don't I don't have to care? So without going to paid exchange, from here can give me one line argument to say that the competitive ratio of bit is at most 7 by 4. We've done this over and over. So I'm claiming that I'm actually done if I don't have to worry about the paid exchange. Can somebody just give me one line justification? What is the total cost of bit algorithm?
Have to sum over.
Exactly. So if you sum left hand side and right hand side, what do you get? The cost of bit across all time plus this summation of delta phi of t, where everything other than the first and the last term will cancel, and I know that both of those are non-negative. And the right hand side is just 7 by 4 times the total cost of the OPT, and I can claim what I want. So all I have to worry about is what if OPT does a paid exchange. So do I need to care or don't need to care? So suppose OPT does a paid exchange. How much cost does it pay to do one paid exchange? Its cost is 1 for one paid exchange. And how much is the change in potential function that can cause? So change in potential function, which is, remember, phi of t is phi 1 of t plus 2 times phi 2 of t, where phi 1 and phi 2 are type 1 and type 2 ordered inversions, number of them. So if OPT does a paid exchange, what is delta phi of t or expected delta phi of t? See, the worst case, it can create one new inversion, right?
Yeah.
And what type will it create? That is not under its own control.
Yeah, it's 50-50.
It could either create it with respect to a type 1 or type 2. And that happens to be with probability half and half. So the best thing it can do is, or the largest increase it can make to the potential function is, how much is this? 3/2. Do people follow this? That the change in potential function because of a paid exchange can at most be 3/2?
Yes.
Because what all can it do? It can create one new ordered inversion. And that one ordered inversion could be a type 1 or type 2 uniformly randomly, because it doesn't control the bit index of the algorithm bit. All right. So now can people finish this argument that given that I have done this, that for each exchange, I have to increase the cost by 1, and for each paid exchange, the increase in potential function is at most 3/2. So then what is the expected cost of C bit? As before, it is K plus I, right? But now what is the cost of OPT? C OPT is now K plus 1. K is the location of the file requested plus 1 for a paid exchange. Agreed?
Yeah.
Yeah.
So this is how much? This is COPT T minus 1 plus I. And what about the expected number of okay, so expected number of new inversions created?
It's 3/4 of K. And
So
plus
we had
3/2.
earlier plus another 3/2,
Yeah.
right? So if I add these two things together, expected C bit T plus expected value of del phi of T.
It's become 3/4 K plus 1.
Right, so let me just add everything. COPT T minus 1 plus I, or minus I for R plus T, and plus 3/4 K minus 1 is now, how much is it? K plus 1 is the cost. So just to make sure, this COPT minus 1 plus a 3/2. Have I done everything correctly? This is correct. This is correct. This is correct. Okay. So how much do I get finally? 7. So 7/4 is clear, and this guy cancels. So -1, minus 3/4, and plus 3/2. So is this positive or negative? 7/4 COPT. So I'm done. All right. So 1 was not important. You can do as many as you want. Because it's additive, I didn't have to do for more than one paid exchange. You do as many as you want, you will pay similar cost. All right, so we are essentially done. As I said, if you add this up over, so summing it over, T goes from 1 to capital T, and using the fact that phi 0 is 0 and phi t is greater than or equal to 0 for t, this implies that new bit is at most 7. There are better algorithms than 7/4, and we will not be covering that in class. There's something called timestamp, which uses bit and another algorithm an additional layer of randomization. So that's conceptually it's not very different. So this will essentially end our